Okay, so I just wanted to do another couple examples on radius and interval of convergence. So let's look at this first one. Let's put it right down here. Okay. So we're going to do a ratio test. So 1, actually I could even write it as x plus 2. Now k plus 1 plus 5 is k plus 6. We need the limit to be less than 1. We do our algebra. Okay, we take our x statement stuff and put it out front. So we have x plus 2 multiplied by the limit as n approaches infinity of k plus 5 over k plus 6. It has to be less than 1. The limit statement, oh, I'm sorry, it's as k approaches infinity. I'm doing that wrong the whole time. Okay. The limit inside here is 1. Okay. So it's just 1. So again, I have x plus 2 multiplied by 1 has to be less than 1. So I have x plus 2 has to be less than 1. So remember, we solve this. So I subtract 2 from both sides, and I have negative 3 and negative 1. And then I need to go back and just decide, will those endpoints work? Well, if I go back up here, and let me just kind of do this here. If I do negative 3 plus 2, I get negative 1 to the k. It's alternating. So negative 1, k plus 5, that is an alternating series. It is conditionally convergent. So negative 3 works. Okay. Negative 1, however, negative 1 plus 2 is positive 1. Well, 1 over k plus 5 is divergent. So our interval of convergence is this, okay, and our radius is just 1, because that's half the distance between the endpoints. Now this other one, we need to actually come up with a series first. So let's see if we can't do that. Okay. It looks like we're multiplying by 2 every time, so we're going to have a 2 to the n. It looks like we've got an x to the nth power, and it looks like we've just got an n on the denominator. Okay, we're multiplying by 2 every time, and we're gaining an x term every time. And you'll notice that whatever x term we have, when it's x to the 4th, we also have that power. When it's x to the 3rd, we also have that power. So doing the interval of convergence, let's do this, set up our ratio test. Okay, let's do some algebra. Let's bring our non-n stuff out. Okay, so I have 2x, limit as n approaches infinity, n over n plus 1 must be less than 1. Again, focus on the limit statement. This is 1. Okay. So I end up with 2x must be less than 1. So I've got negative 1/2 and positive 1/2. And looking at this, if I plugged in negative 1/2 up here, I'd have 2 to the n and negative 1/2 to the n. Well, that would be negative 1 to the n over n. That's a convergent alternating series. If I plugged in positive 1/2, 2 to the n, 1/2 to the n would make just 1 to the n, 1 over n. is not. So this is my interval of convergence, and of course my radius is half of it, so the radius is 1/2.